Okay, so in this video, we're going to look at the 5 main types of reactions, how to identify them, and that's pretty much it. Not too tricky, okay? How to figure out those types of reactions. Okay, so there are a bunch of different types of chemical reactions, okay? Obviously, there's a whole bunch of chemical reactions happening all the time. There are 5 main types that we're going to go through, and they are not complicated at all. Really, typically, all you need to do is just be able to look at a reaction and identify, aha, that's a synthesis, or that's a combustion, or that's a whatever, okay? So here we go, all right? The first type of reaction is called a synthesis reaction, okay? Almost everyone calls it a synthesis reaction. Some books, like yours, call it a combination reaction, okay? Means the same thing. So a synthesis reaction basically just means you take 2 things or more, take multiple reactants, and you smash them together to one product, okay? I'll need to write that down, you get it, okay? So you have like A plus B, and you're smashing those 2 things together to make AB, okay? So I don't know why. We always have like the generic, we use A's and B's or X's and Y's. I don't know why we do that, but just for fun, in case you're trying to, use the Google or look in your book and you're seeing this thing, now you know what this means, okay? So you have 2 different reactants, you put them together, you make one product. So a good example of that, like a real equation, would be you have nitrogen gas plus hydrogen gas, you smash them together, and you make ammonia, okay? This is a synthesis reaction. 2 reactants smashed together to make one product, okay? This isn't balanced, so of course you would want to balance your equation and make sure you know how to do that, right? But 2 nitrogens on this side, I need 2 nitrogens on this side, so now I have 2 times 3, so 6 hydrogens, 6 hydrogens, now I'm good, okay. But this is synthesis, okay? You take 2 or more things, put them together. That's easy, okay? Type number 2, decomposition reaction, okay? Decomp. Everyone knows what this means, right? We know what it means to decompose, all right? Gross. But if you're thinking about something that's decomposing, it's breaking apart, right? Breaks apart. So it's basically the opposite of synthesis reaction. You're starting with some kind of big compound, and it breaks apart into its different separate pieces or different elements, okay? And a real life example of that would be copper 2 oxide, which is going to break down to copper solid, and oxygen gas. And oxygen gas is always O2, right? So if you see this, make sure you don't say it's just Cu plus O. It's plus O2, okay? And again, this would not be balanced. 2 oxygens, 2 oxygens, 2. There you go, okay? But there you go. Decomp, you start with one thing, you break it apart, okay? So far, easy. All right, then we get single replacement reaction, okay? Your book, what does your book call it? It calls it displacement, okay? Single replacement or displacement reaction, okay? This I like to lovingly call the home wrecker. Okay, what this means is you have a nice couple, right? You have an A and B. You have a nice couple. Maybe it's Jennifer Aniston and Brad Pitt. I don't know. Okay, and they're nice and bonded. You've got this nice happy couple, and then a single comes along. Okay, ooh, I don't know who we'll call that one, all right? But what this single does is it breaks up the couple, okay? You have a home wrecker, and it's going to displace, or a single replace, it's going to replace the other one of that couple. Okay, so it's kicking someone out of the way and it's going to bond to it instead. Honestly, okay, single replacement reactions, these are the trickiest, I think, of all of the 5 types of reactions because it can happen 2 ways. All right, so if the single, right, if the guy that's going to come in and replace you is a cation, if this is a metal, it's going to replace the other metal. If this is a non-metal, it's going to replace the other non-metal. So you have to be really careful about what you're actually making. So if this was a metal, right, if this was a cation, it's going to replace the other metal. So this C would replace the A to be then Cb plus, now A is all by his lonesome, okay? So the metal would replace the metal. If it was AB plus C, and C was a non-metal, it's going to replace the other non-metal. Okay, so this C would swoop in and kick B out of the way then. So this will be A bonded to C, and now B is all by its lonesome, okay? If this, like, hypothetical A's, B's, and C's doesn't make sense, let's actually look at some real examples that I wrote down. Okay, so if you had aluminum plus copper 2 sulfate, okay? If this is going to react, okay, I have a nice little couple, yay, and a single, got my home wrecker, okay? The aluminum is going to swoop. Aluminum doesn't want to bond with the copper. It wants to kick the copper out of the way. Okay, the metal wants to kick the other metal out of the way and take its place. So what's going to happen is now copper, oh, is by itself. Ooh, a different blue. That's neat. And aluminum is going to take the place of copper and bond to your sulfate, okay? And this is the trickiest, worst part of this because most people will do this. They'll say, okay, now aluminum's going to be here, AlSO4, and they'll be done, okay? But this is not the correct compound for aluminum sulfate, okay? So instead of just straight writing it out, what I would do first, here's what I would do, is AlCuSO4, okay? I do the exact same thing. Aluminum's going to come in and swoop. I'm going to have copper by itself, and then I would take the time to write out the ions. I'm going to get aluminum with a 3+ and sulfate with a 2- charge. So I can just take a second to look and see 3+, 2-, aha. So I need Al2SO4 3. Okay, this is the correct ionic compound for aluminum sulfate. Then you go back through and fix your coefficients. 2 aluminums, 2 aluminums, 3 sulfates, 3 sulfates, 3 coppers, 3 coppers. Now the balanced chemical reaction with a product that actually exists, right? This is no good. So just be careful of that, okay? So this is the case if the single is a metal. We'll look at a different one if the single, like this, I had NaCl plus F2. Okay, so in this case, my single is fluorine, even though it says F2, right? Because fluorine is diatomic, but still just F. It's still just the element of F. It's not another couple, okay? Like Na is a cation, Cl is an anion. So I have a cation and I have a couple. Fluorine is just one type of atom, okay? All right, so this fluorine is going to swoop, and it's going to kick chlorine out of the way now, okay? Fluorine doesn't want to bond with chlorine. Fluorine wants to bond with sodium, okay? So the anion is going to kick the other anion out of the way, and I'm going to get now NaF, sodium is bonding with fluorine, plus chlorine is all by itself. And again, this is why I would take the time to actually write it out. Write out your ions, right? Na has a +1, F has a -1, so this happens to work out to be NaF. Chlorine is one of your diatomics, so this is Cl2. And don't forget to then Cl2, 2, 2. Okay, Single replacement's the worst, trickiest one, okay? Because you have to first figure out, you know, is this a metal, so it'll replace the other metal. If it's a non-metal, it'll replace the non-metal. And then also the worst part about single replacement reactions is you have to follow the activity series for metals. If you don't know activity series or what that means, I'll figure out whatever it is to link or something. Okay, but make sure you do this to see if there is actually a single replacement reaction or if there's going to be no reaction. Okay, that was the longest one. We're almost done. Yuck. All right. Type number 4. Not just a single replacement, but now I'm going to have a double replacement reaction. And your book, of course, comes up with a different name for it. They call it an exchange. That's nice. I call it wife swap. Okay, so if you think about it the way I do, which I'm sorry if you do, I guess, now you have two couples, okay? You have two different compounds, AB and CD. Two nice, happy couples, but they're gonna wife swap, okay? So to keep everything straight, what I would do is I would just flip-flop the anions. Leave the cations where they are. Just flip-flop the anions. So now I'm going to get A, instead of being bonded to B, he's going to bond to D. And C is going to be bonded to B. Okay? And an actual example is somewhere. Potassium iodide plus lead 2 nitrate. Okay, react to make something. So I'm going to wife swap. I have two couples, cation, anion, cation, anion. Okay, flip-flop the anion. So I'm going to get potassium with a +1, bonding to, not iodide, but nitrate. Take the time to write out the ions, okay? It'll help, I promise. Then you get lead with a 2+, and you know this is 2+ because there were two nitrates. Okay, so nitrate is a 1-. There's two of them, so there's a total of 2 minus charges here, which means this lead had to be a 2+. So I have lead with a 2+, bonding with iodide, which is a 1-. Okay, so now I can make my appropriate and correct ionic compounds here. So this will be KNO3 plus PbI2. I need 2 iodines to balance out that 2+ charge. Okay, and then you balance 2 nitrates, 2 nitrates, 2 potassiums, 2 potassiums, 2 iodines, 2 iodines, 1 lead, 1 lead. Yay! Phew. Okay, last one. Combustion. Okay, boom, explosion. That's me drawing an explosion. Hope you liked it. Okay, so a combustion reaction is anything that has, you basically have a substance plus O2. Okay, because fire or explosions, right? They need oxygen to survive. So most typically, okay, typically you get a hydrocarbon, which is just carbons and hydrogens. Okay, you get some amount of carbons, some amount of hydrogens, plus oxygen, and you're always going to get carbon dioxide and water. Okay, this is the most typical type of combustion reaction. There are other ones that break the rules, but this is the typical one. Okay, so the really easy example would be like CH4 is methane. That's what comes out of your, like if we turn on the Bunsen burners in lab, okay, methane is what's coming out. If you are cooking on your stove and you have a gas stove, you turn on the stove, methane is coming out of your stove, okay? So methane plus oxygen reacts to make carbon dioxide and water. And then you would just balance this mother. 2 oxygens, 1, 2, 3 oxygens, ooh, 1 carbon, 1 carbon, 4 hydrogens, 2 hydrogens. Okay, this is easier. So you have 2, I have 1, 2, 3, 4 oxygens, 4 oxygens, hooray. Okay, this is a combustion reaction. You have some substance plus oxygen. Okay, you've got a nice little explosion or fire, make carbon dioxide and water. Okay, there are a couple of ones that will break the rules, so just so you can see the typical rule breakers, I guess. Other common ones for combustion. You'll see like CS2 plus O2, H2S plus O2, NH3 plus O2. I think this would be the most common one that they'll try and trip you up on. They'll put ammonia plus oxygen. I think that would be the most typical one they'll throw in there to say, what type of reaction is this? And you'll be like, ooh, it's not a hydrocarbon, but it is plus oxygen. Okay, so just be careful of that. And the other weird thing about combustion that they might throw at you is sometimes you'll have like an S plus O2 making SO2. So you'd think, aha, synthesis. True. Also combustion. So this would be a synthesis and a combustion reaction. Okay, it's both types in one. Because I have two different reactants I'm smashing together to make one product. So it's synthesis, and it's a substance plus oxygen making products. Okay, so combustion can be kind of tricky. Worst one by far is single replacement. Okay, those home wreckers, they're the worst. All right, hopefully it's not too rough. This is the longest video ever. Good luck. All right.